hang up and try again.
The following example will consider a string and a character, and the idea is to count how many times that character appears on the string S. You can see right now the answer using a loop. First of all, we consider a character and a string S as a parameters. We have an accumulator called total, which basically will be returned at the very end after executing this for loop. The for loop is the traditional for loop that goes from index 0 all the way to the length of the string, one by one. Inside of the for loop, we count with a condition. This if statement will count the number of times that the character C appears in the position I. Notice that s.char_add will return a character that is at position I. I is a control variable that will count from 0 all the way to length. In other words, every time we visit each character for the string, we're going to compare it with the target that we're looking for, C. If it happens to be true, then we're going to increment our accumulator by 1. If it happens that they don't match, then we don't have to worry. We're just going to move for one more position, and that's pretty much it. Let's compile and run this program with the string bananas and the character A. So we notice that there's 3 times A that occurs on bananas. And there they are. Now let's translate our method using our formula. The very first thing is to replace our loop into a while loop format. So let's translate this for loop into a while loop. We recognize that the while loop and the for loop both are pre-test loops, so they're equivalent. We only change this for the format of the recursive translation. The next step is to use the loop condition to create the recursive and the base case. The recursive case will be the if statement that consists on what is inside of the body of the loop. The base case is the else statement that is exactly what is outside of the body of the loop. So we have this while will be transformed in a recursive case by changing it to an if statement. What is outside will be our base case. The next step is to supply our self call in the if statement. I'm using Visual Studio Code, and you can tell right away that it's providing you an error here. This method must return a result of the type int. This is an indicator that in runtime, it identified that you don't have a return statement. Since you have an integer as a return type, we need to check that before we type a return type. If it's void, then you can just call the name of the method. However, in this case, since we're returning an integer, the data type is required and we need to use a return. Make sure you include the same number of arguments in order to satisfy the condition of the method call. The next step is to separate the local variables into the method's arguments, then update all the method calls. Notice that here we have 2 local variables, total and I. So what we're going to incorporate into our arguments are going to be the values of total and I. These local variables with appropriate values, we're going to migrate them into the main. Don't forget to update the current method calls. Similar in the recursive case. Let's save, compile, and run this program, and let's see what we got. The same result. Notice that we don't have any loop in our method, and it's doing what we were expecting to. This is not as elegant as we want. Since we want to achieve elegancy, we need to do more steps here. The next step is to improve the number of arguments. So instead of using irrelevant variables for counters, we should just focus on the main control variables. Pay attention that in this case, we need to iterate through the entire string. Therefore, we need a control variable that helps us to navigate from position 0 all the way to dot length. In this case, we do need the variable I because there's no other way to just navigate through the entire string. I know what you're thinking. There are some methods like, for example, substring that can do the trick, but that is assuming that you're considered to have this type of functionalities. So we can keep I. What we need to do is that we need to interchange the postfix operators into infix operators. In this case, I++ will be interchanged by ++I. The next step is to add the accumulator onto the self-call statement, which is the stack. Notice that the total plus plus is only being affected by the if statement that is located on line 11. Notice that the total plus plus only updates the value of total by 1, that we can just add 1 to our recursive call, which is indeed what we want. Now notice that that happens if the characters happens to be the target for that particular condition. But how about if it's not? We still have to move forward. That's why, in case that condition is not true, we can simply call ourselves without adding 1. Notice that pretty much we got rid of total, so we don't need total anymore. The last step is that we need to negotiate on what the method will return in the base case, which is this case. Notice that we don't have total. Therefore, we need to provide a value that does not affect our sum. You remember that that value is 0. Let's go ahead and compile and run this program. Indeed, we have the same result.